Welcome to the Day 2 video for Chapter 8, which is solving exponential functions. So we're going to do two things today. First one, we're going to solve exponential equations by getting the same base, and we're going to model a situation using exponential growth or decay. For the first part of the video, you are not going to need a calculator, but for the second part, you will. So the golden rule for today's video is bx equals by if and only if x equals y. So basically what I'm saying is when the bases are equal, I can set the exponents equal. So for example number 1, my two bases are equal, 2 and 2 are equal, so I can set my exponents equal. 3x equals 4, so x equals 4 over 3. Now, it's not going to be so easy today. I'm not going to give you the same bases right off the bat. You're going to have to get them. So let's look at example number 2. Example number 2, you're going to notice we have different bases. We have a base of 2 and we have a base of 8. So what we need to do is we need to try to get the same bases on both sides. Now, 2 I can't write any other way. 2 is just 2. So I get 2 to the x. Well, 8 I can rewrite though. So I'm going to keep that third power. How can I rewrite 8? Well, 8 is 2 to the third. So this is 2 to the third. So my left side stays 2 to the x. Now, on the right side, because of the properties of exponents, I'm going to multiply those 3's. So I get 2 to the 9. Or 2 to the 9th power. Now, because my bases are equal, I get x equals 9. Okay, so example number 3, I would like you to try. I'm going to tell you that you cannot re-express 3, so that 3 on the right side stays. You need to figure out some way to re-express that 9 on the left side in terms of 3. So pause the video right now and try this one on your own, please. Okay, let's see how we did. Now, hopefully you figured out that 9 is 3 squared, and then to the power 2x minus 1 equals 3 to the power 6x. Now, what's tricky is remembering to distribute this 2. So this becomes 3 to the power 4x minus 2 equals 3 to the power 6x. Now, you have to remember that you're multiplying that 2 by the entire exponent. So you might have made a mistake there. Now, because my bases are the same, I can set the exponents equal. So I get 4x minus 2 equals 6x. Subtracting 4x, I get negative 2 equals 2x. So x equals negative 1. Okay, so hopefully you got that one right. If you didn't, that's okay. We're going to get some more practice with a few more examples. Okay, so looking at example number 4. Now this one's trickier because I have this 1/2. So 4 should be easy to re-express, so we're going to re-express that 4. 4 is 2 squared. Okay, so on the right side, I have a power of 2. That means on the left side, I need to get a power of 2. Well, hopefully you remember that 1 over 2 is just 2 to the negative first power. So 1/2, that's just like 1 over 2 to the first, which is the same as 2 to the negative first. So when I move it, the exponent becomes negative. So this is really 2 to the negative first power. So that's negative 1. Now distributing, and I get 2 to the negative x equals 2 to the power of 6x. Now because my bases are the same, I can set the exponents equal. So I get negative x equals 6x. Adding x, I get 0 equals 7x. Okay, this is not no solution. I think a lot of us at this point are like, oh, okay, no solution. No, that's not true. Divide by 7, and I get x equals 0. Okay, so example number 5 is a little bit trickier than what we just did, but this is where you're going to try it. So right now, pause the video and try example number 5. It's similar to what we did in example number 4. Good luck. Okay, so let's see how we did. Now, 27 should be easy to re-express right off the bat. 27 we know is 3 to the third. Now, how do I express that 1 over 9? Well, we know that 9 is 3 squared, so 1 over 9 is going to be 3 to the negative second. Okay, now multiplying this becomes 3 to the negative 4x equals 3 to the 12th. Now, because my bases are equal, I can set the exponents equal. So negative 4x equals 12. Dividing by negative 4, I get x equals negative 3. Okay, so the key is to know that when you have a fraction, it's going to be a negative exponent. And you should remember that from the properties of exponents. When you have a negative, it gets moved from numerator to denominator. It's like taking the reciprocal. So that's the key to these types of examples. Okay, so that was the first part of today's lesson, is solving these exponential equations. And this is really important. It's going to follow us the rest of the chapter. But now we're going to move on to something else. So flip the page, please. Okay, so in example number 6 and 7, we're writing the exponential function that passes through the given points. This is where you're probably going to need a calculator. So I'm going to give you first the general form of the equation. So our general form is y equals a times b to the x. Okay, so in your equation, y and x are going to stay there, but a and b are going to be some numbers. So that's what we need to figure out. So let's substitute in that first point. Remember that x is 0 and y is 125. So I get 125 equals a times b to the 0 power. Now b to the 0 power is just 1, so that goes away. So I get a equals 125. So now my equation is y equals 125 times b to the x. Now that's where that second point comes in. That second point is to help us find what b is. So if I substitute that point in, I get 1,000 equals 125 times b to the third. Now, let's divide by 125. And I get 8 equals b to the third. Now, how do I get rid of that third power? Well, I'm going to take a cube root. Okay, so cube root and third cancel out, so I get b equals, the cube root of 8 is 2. Now hopefully you remember 8 is 4 times 2, 4 is 2 times 2, so the cube root of 8 is really the cube root of 2 to the third. So those cancel, that's how I get 2. So my final equation becomes y equals 125 times 2 to the x. Now you cannot simplify that. You can't multiply the 125 and the 2 because the 125 doesn't have an exponent. Okay. So now you guys have example number 7 to try. Right now, pause the video and try example number 7 on your own, please. Good luck. Okay, let's see how we did. So we're going to start off with y equals a times b to the x and substitute our first point in. So we get 144 equals a times b to the 0. So we get a equals 144. Our equation then becomes y equals 144 times b to the x. This is where you should have substituted your second point in. We get 21,609 equals 144 times b to the fourth. If we divide by 144, we get b to the fourth equals 150.0625. Okay, now at this point you might have gotten stuck. You might have said, well, what do I do from here? Well, with example number 7, we took the cube root of b. Over on this side, we need to take the fourth root of b. Now, my guess is that you probably don't know how to do that in the calculator. So instead of doing the fourth root, what you can also do is take to the reciprocal power. So raise to the 1/4 power. So if I raise to the 1/4 power and the fourth power, those cancel. So I get b equals. So in your calculator, you should do 150.0625 to the power, so the caret button. So you're going to do 150.0625 caret to the power 1 divided by 4. You have to make sure that 1 divided by 4 is in parentheses. And that gives you 3.5. Okay, so now our equation equals y equals 144 times 3.5 to the power of x. And that's your final answer. Now I know that's a little bit confusing, a little bit new on the calculator. So if you're confused on that, please make sure you star this example so that you know to ask your teacher about it in class tomorrow. Now the reason that we're writing these exponential functions is so that we can do word problems that model exponential situations. So let's look at example number 8. It says, Kristen starts an experiment with 7,500 bacterial cells. After 4 hours, there are 23,000 cells. Write an exponential function that could be used to model the number of bacteria after X hours. Okay, so first thing that we want to do is define what our variables are. So it already tells us that X is the number of hours. So then Y in this case is going to be the number of bacteria. So we're told that she starts an experiment with 7,500 bacteria. So after 0 hours, so at the start, there's 7,500 bacteria. Then it says after 4 hours, there are 23,000 cells. Okay, and now this looks exactly like what we just did. We're just going to model this using an exponential equation. So we get y equals a times b to the x. Substituting our first point in, we get 7,500 equals a times b to the 0 power. B to the 0 power is just 1, so we get a equals 7,500. So then, when I substitute my second point in, I get 23,000 equals 7,500 times b to the 4th. So if I divide 23,000 by 7,500, I get a decimal, so turning that into a fraction, it's 46/15, or 3.06 repeating, equals b to the 4th. Okay, then we talked about to get rid of that 4th power, we can either take the 4th root or we can raise it to the reciprocal power. So I'm going to raise to the reciprocal power. So those cancel, and I get b equals, in my calculator, I'm going to do 46 divided by 15 raised to the power, so caret 1 divided by 4. And I get b to be 1.323 about. So my equation becomes y equals 7,500 times 1.323 to the power of x. Now what I need you to remember at this point in time is that that 1.323 is a rounded value. So that's not actually the value of b. The value of b in your calculator was 1.323 and then this really long decimal. So we just rounded it. So keep that idea in your mind for right now that that is actually a rounded value. And we're going to address that issue in a minute. So in the second part, it says how many bacterial cells can be expected in the sample after 12 hours. Okay, so hours is x, so this is telling us that x equals 12. Okay, so using our equation, we're going to get y equals 7,500 times 1.323 raised to the 12th power. Now what we need to remember at this point is what I just told you. This is actually a rounded value. Now if we use a rounded value when we try to estimate the number of bacteria cells after 12 hours, that rounded value is going to give us a number of bacterial cells that's a little bit off. So really we want to use the true value of b. So if you would take out your calculator right now, if you have not already, and follow the steps with me. Okay, so the first thing that I want to do is review how to find that b value. So remember that for b, we took 46/15 and we raised it to the 1/4 power. So you would put in parentheses 46 divided by 15, caret, and then remember that power has to be in parentheses, 1 divided by 4, end your parentheses and hit enter. Okay, now this is your b value. So like I said, we wrote down 1.323, but really b was 1.323325, etc., and it's going to keep going. That's the value that I want to use. So right now, hit the store button. It's that button that's shown in red right above the on. So you're going to hit stow, the X button, and then hit enter. Okay, so what you just told your calculator is I want to store that value, 1.3233, etc., as x. So now the calculator is saying in its head, every time that you push x, that number 1.3233, etc., is going to come up. Now we're going to use that to approximate the number of bacterial cells after 12 hours. So we're going to do 7,500 times, okay, now here's where we would put that 1.323. Instead, we're going to put x, because we told the calculator store that value as x. And we're going to raise it to the 12th power and hit enter. Okay, so this is the true number of bacterial cells, or what we would estimate the number of bacterial cells to be after 12 hours. So I'm going to write that. We're going to estimate to be 216,302.2 repeating bacteria cells. Okay, so at this point, I'm betting some of you are still asking yourselves, why am I even bothering to store this value? Why can't I just use 1.323? So let's see what answer we would get if we used 1.323 instead of storing the value. If we did that, if we did 7,500 times 1.323 raised to the 12th power, this would be our answer. Okay, so now you should notice those answers are pretty different. 216,000 as compared to 215,000. There's almost a difference of 1,000 cells. So when you round that value of B, that makes a big difference in your answer sometimes. So we're going to expect you to store that B value when it's a decimal as x, so that it's easier for us to work with and so that we get a more accurate answer. If you're confused on this, your teacher will go over it in class again tomorrow. Right now, we are going to move on to the last example, which is a word problem that you're going to try. Now, before you jump into the word problem, I'm going to help you set it up. So it says a manufacturer distributed 3.2 million aluminum cans in 2005. In 2010, the manufacturer distributed 420,000 cans made from the recycled cans it had previously distributed. Assuming that the recycling rate continues, write an equation to model the distribution each year of cans that was made from recycled aluminum. Okay, so as you know, this is going to be a problem that you do, but I would like to start the problem out with you. So there's two things that we're looking at. So we need to determine what's our x and what's our y. Okay, so we start out in 2005. So x is going to be the number of years since 2005. Y is going to be the number of recycled cans from the original 3.2 million. Okay, so that part's tricky. We're not looking at all recycled cans. All we're looking at is how many cans each year are recycled from that original 3.2 million. So before you can write your equation, you're going to need to write two ordered pairs. Okay, so the first one is in 2005. Well, in 2005, that's 0 years since 2005. And then it's 3.2 million. Now, we have 3.2 million, and then all of a sudden we switch to thousands. So we need to pick. We're either going to count in millions or we're going to count in thousands. I'm going to count in thousands. So 3.2 million written out is 3,200,000. So that's a 2. 3,200,000. That's the same as 3.2 million. And then in 2010, so that's 5 years since 2005, there were 420,000. Okay, so right now you're going to have your equation y equals a times b to the x. You need to find a and b. So pause the video, find a and b, and then answer the second question. Good luck. Okay, I'm not going to show you how to do this problem, but I am going to tell you what the answers are. So your a value should be 3,200,000, how much you started with, and your b value should be about 0.67. Now, you should have stored that as x in your calculator. When you do that, and then you answer the second question, you should get an answer that's pretty close to 0, so about done. Now, if you did not get about 0, or you got A or B wrong, that means that you did the problem wrong and you need to go back and redo it. Please make sure you have the correct answer. When you come to class tomorrow, we'll be checking to make sure that you have all the work and all the correct answers. Please write down any questions that you may have. Good luck and see you tomorrow.